You're listening to Strange by Nature, your guide to the strange, weird, unbelievable, and improbable wonders of the natural world.
Hello, everyone. Thanks for being here today. I am Kirk Mona, and I am joined today by Rachel Ginza and Victoria Thompson. We are all professional naturalists who together have scoured the world for weird and wonderful wonders just to please your mammalian brain's desire for novelty. Isn't that nice? Let's do this.
I get to start us off this week. And
Awesome.
I am, as always, I'm excited. So this week I am covering the Harpia, or the Brazilian or American harpy eagle.
Ooh,
Yeah.
cool.
Which
It's
was,
about time.
right? It's been on my list for a little while. And I thought I might as well try it because they're terrifying. Anyway, so they were first described by our man.
Terrifyingly awesome.
Yes. By our man Carl Linnaeus. They were first described in Western Science in 1758. They are endemic to like Panama, Brazil, hence Brazilian. They reach all the way through Venezuela and French Guiana, Ecuador, and just that whole swath.
Mhm.
And I just want to point out, I'm really glad you said first described by like scientists, because I think the first description was by monkeys who said, "Oh God, oh God, oh God."
As they should, because whew. So these are one of the largest and most powerful raptor in that particular range, and they're one of the largest eagles in the world. They live in the lowland forests in the canopy layer of the rainforest, and they're technically near threatened or in the range of starting to be worried about, since the rainforest, their habitat is starting to go away. So, the harpy eagle. They are, when it comes to, they can live anywhere from 25 to 35 years in length. But for description, because that's what we all want, they are a large bird with
So
the
far, so
underneath,
good.
right? So to describe the harpy eagle, the upper side of the harpy eagle, so the back, is covered in these slate black feathers, so they're very dark, which I would think wouldn't work very well for a bird that hunts in the rainforest, but it works for them for sure. The underside is actually mostly white, so they have contrast coloring, except for the feathered, it's called a feathered tarsi. So it's around by their feet. So they have like a little black feathering around their feet.
Like little boots.
Like little boots.
Hmm.
They have a broad black band across the upper breast that separates the gray head from the white belly, and the head is more of a pale gray. And it has a double crest crown. So
cool.
you think
So
of like
cool.
a cockatiel or a cockatoo. They have the crest that comes up, or like a cardinal as well has a really crested head. These have a legit like crown that goes around their head, kind of like trying to many. And I realize that this is a science podcast, but this is very much just how holy figures were depicted in like especially medieval and Middle Ages art, like a ring around their head. It's
I believe the word you're
feathers.
looking for is a halo.
Okay, that works too. I was trying not to say that word, but okay. Yes.
That's
So
fine.
We're
yeah,
not
It's
we're
a
not
legit
promoting
word, yeah.
any particular religious ideas, Rachel. You're just describing some art.
that's also true. Yes. So it has
It's
this
also the
double
name
crest.
of a video game, if you want to go down that road.
Mm.
You're right. You're right. Also, I will say I did forget the word halo. there is that.
Oh, perfect. Well, there you go. The
So
truth
it has
comes
this.
out. It's like this thing.
It's this
Like
thing
a,
around. I'm playing
like here's
Pictionary.
get on your phone or open up the Googles and type in Harpy Eagle, and you'll see what she's talking about.
Also, they have a
It's-
death glare, even more than
They
most raptors.
do.
Oh yeah.
Just horrifying. So they have that halo of feathers that goes around and makes them look even larger than they already are. One thing that I found was amazing and kind of scary. Their talons on their feet
Yes.
are about 5 inches long.
Oh,
Wait. The talons, or like the talon plus the toes?
Talon plus the toe.
Okay.
I take that back. Yeah.
Woo.
Talon
Yeah.
plus the
Wow.
toe. But
Still
Picture a
large.
5-inch talon.
okay, it's the talon plus the toe. But they have one of the strongest this is a little graphic way, sorry everyone. Please preview if you children are listening, I guess. But
I think you all know what podcast you're listening to. Go for it.
right. So the grip of a harpy eagle, if it can very easily crush and go into a skull. Like
A human skull.
A human skull, yeah. Very easily. Like it doesn't require a lot of force for that.
And they know this
have enough strength in
because
Yeah, have you tested this, Rachel? What's the...
I'll never tell my secrets. No.
Oh,
No, they were able to measure the force of the grip of the bird, and there's enough science in how much force it takes to break bone, especially skull.
Mhm.
Trying to picture 5 inches. They could probably get a
yeah.
hold of your skull.
Yeah, I will say when I started doing research, one of the like frequently asked questions about harpy eagles was, can they attack people or like fly people away or something like that? I'm
Like
like,
the hobbits.
okay.
Wow.
No.
No.
Yeah.
And no.
But the birds themselves, they are fairly large they are fairly large.
They're very muscular looking.
Yeah, they're very muscular. Their body length, including not including their head, I suppose, is 3 to 3.5 feet, so about a meter. Their wingspan, however, is 6.5 feet, so 2
Nice.
meters.
Yeah.
And they weigh anywhere from 9 to 20 pounds.
That's a
That
big
is
bird.
quite a range.
Yeah.
Yeah.
When I was talking about their talons before, to give you a little context of the size of their talons, so the whole toe is 5.1 inches, but with the talon itself, it's the same size as a grizzly bear claw.
Okay.
So about 3 to 4 inches long. Most of that
Wow.
is the
talon.
the talon, which just scared me a little bit, is all. Yeah, and there's just lots of different things about the harpy eagle that were just fascinating, and I really wanted to talk about just the pure size of the harpy eagle. One thing that they tend to eat, they are the top of the food chain, as you could guess from just purely their size. Their main prey are tree-dwelling mammals. Like
Such
sloths
Oh.
Poor little
and
sloths.
monkeys.
Yep, there it is.
Mhm.
Yup.
Gosh.
Yeah.
That's just, oh my gosh.
If their prey is too large, they will just put it in the tree and peck at it and come back later for it.
Oh, good.
I mean,
Right?
makes sense.
Waste not, want not.
Yeah. but they will also like anything that is partially arboreal or even land mammals will be preyed upon, like porcupines, squirrels, possums, anteaters, armadillos. They'll go after kinkajous, tyra.
Wait, Pikachu's? Is that what you said?
No, kinkajous.
Oh, I heard Pikachu's, and I was like, I didn't think those were real.
They're
Debatable.
they're
I'm
they're
picturing
described as like the
I'm
honey bear, like a common name.
picturing like I was picturing like a harpy
Picture-
being like, I gotta catch them all.
Think
Gotcha.
weasel.
Noted.
Like large weasel. They've also been seen preying upon an agouti, which is large. They've also been recorded taking domestic livestock, including chickens, lambs, goats, young pigs. They don't tend to do that just because they can have all the monkeys they want, apparently.
The
Yeah.
harpy eagle can have
want-
whatever
I
it
want-
wants.
I want a T-shirt with like a harpy eagle head on it, and it's like, I get all the monkeys I want, or something like that.
Maybe later. Most commonly, they're perch hunters, so they scan for prey activity, and then they do short flights from tree to tree, and once they spot it, they just dive down and grab it, and in that grabbing, they puncture the heart or some other major vessel, and well, you're dead. You are
Did
now
you find
eagle
any?
feed.
Do you know like how far into the canopy are they going? Because this is a big bird.
This
and
is
I
a
think
big
about,
bird.
to
Yeah.
be getting through that canopy into any kind of lower levels
With
of the
a
forest.
6.5-foot wingspan.
Mhm.
Yeah, I mean, you got to be just kind of skimming the surface.
You would think so. They are in the canopy itself. So the upper layer of the canopy still,
Okay.
but they are in the canopy. Which is
I
like
wanna-
the top
sometimes
part of
these
the
have like
forest anyway.
super canopy trees that stick out too. You know.
Mm-hmm. They
in
will
that
also like have been observed hanging out near an opening, like a
Okay.
high point near an
Mhm.
opening or a river
Sure,
or a salt or a salt lick.
Yeah.
They might. Yeah, but for the most part, they are a forest dwelling raptor, which is insane for a bird with a
Unreal.
5 or 6.5 foot wingspan. It's just nuts. Yeah, that's what I wanted to talk to you all about today. I just wanted to talk about the harpy eagle and just how large it is and how nuts it is that there is a bird that is that large just hanging around. It's fine.
Cool, thank you.
When we come back, from our break, it will be Victoria's turn.
Hey everyone, Kirk here. 2021 has been a mentally tough year on a lot of us, and I sincerely hope that this show has been a positive influence in your life. This is the second to last episode of 2021, and we'd ask that if this was a positive influence on your life and made this year a little easier to get through, maybe you consider becoming a member of the Society of Strange and supporting the show over at patreon.com/strangebynature. And we really appreciate everyone who's done that so far and helped us get the show off the ground and keep on going. We are going to be going strong in 2022. Hope to be here for you and have a little escape from everything going on in the world by appreciating all the strangeness in it. So thanks again to everybody who's supported us so far, and we'll see you all in 2022.
We're back. I don't know about you, but I remember as a child looking at a globe and trying to figure out what was on the exact opposite side of the world from me. FYI for Minnesota,
Oh,
this
yeah.
is just
Right.
somewhere in the southern Indian Ocean. Not super exciting.
Nothing spectacular.
No.
That is something good to know as someone who tried to dig to the other side of the world as a child.
Well, exactly. You may have thought as a child that if you just dug a hole that was deep enough, you could get there. And then at some point in elementary school, you learned
a
that the
3-foot
interior
deep
of the
hole.
Earth is a hellishly hot place of molten rock, crushing pressure, and your dreams died.
Maybe a little.
So I'm going to
I
talk.
only ever got like 3 feet down, anyways. So.
Yeah,
Right? You get tired.
digging is
after a
hard
while.
work.
Yep.
So, what exactly is in the center of the Earth? Just for review, there is an inner core that's believed to be of a solid iron nickel alloy. There's a molten metal outer core and a mantle of molten rock that underlies the crust, which is what we walk around on. The mantle is about 2,900 kilometers thick. And the temperature of the inner core is believed to be about 5,430 centigrade, or about 10,000 degrees Fahrenheit, similar to the surface of the sun.
So hot.
Hot.
Yeah.
You
Just
don't
a
want to
bit
be there.
warm.
Mm-mm.
So really, the center of the Earth is completely inaccessible, much more inaccessible than the bottom of the ocean or outer space. And it kind of begs the question, how did geologists know what they know about it?
Yeah, how did they figure that out?
Yeah, so there's data from different places. One is we get data from volcanic eruptions, which makes sense. They're bringing rock up from the mantle, upper mantle. And then there's rocks that have been found in various places that they know by different kinds of analysis are from kind of deep down. And so that can give us some information about the elemental and mineral content of the upper mantle. Geologists have had to make some more inferences about the lower part of the mantle, but it's long been theorized to have different types of minerals that exist down there to have a high pressure, because that kind of pressure just configures the atoms differently. And when minerals like that will rise in the mantle, then they change the composition. They'll still have the same elements in them, but the structure will change.
Right.
Another way they learn about the composition of the Earth is that when there's an earthquake, they can actually analyze the way the seismic waves kind of bounce around. And they can make deductions about the composition and depth of the different layers. You know?
How because it travels different speeds depending on how
depending on
viscous
the composition.
or
yes, exactly. Changes in speed, changes in direction, that kind of thing. The knowledge about the composition of the center of the Earth being made of iron nickel is based on a few factors. The seismic studies, for one, the presence of the Earth's magnetic field tells us there has to be some kind of magnetic material there. And
spinning metallic dynamo.
Indeed. And actually, iron meteorites that have fallen to Earth tell us also a lot, because it tells us it's a very common material in the solar system.
Oh, yeah.
Right.
And then there's also just sort of limitations of what the material could be based on the size and density of the Earth. It can't be something very lightweight, for example. So you remember what I said about the different minerals in the lower mantle being shaped by pressure? So there was some very exciting news this month, which is what I'm actually talking about. All of this has just been background to now. Geologists have for the first time been able to directly observe some of these minerals in a super cool way. They were actually preserved inside of a diamond.
What?
Yes.
How? What? That's amazing.
So
I want to know more.
Yeah, do tell.
So diamonds are formed in the mantle. The ones that you would buy in jewelry are mostly from around 150 to 250 kilometers deep, which is, pretty deep. But some come from some come from as deep as 800 kilometers, which is part of the lower mantle. And basically, this is a gross simplification, and I can't claim to understand everything about diamond formation, far from it, but basically the pressures and heat down there crunch the carbon atoms together and form a diamond.
That's pretty good, yep. Crunchy carbon.
More or less, yeah. Sometimes it is the crunchiest.
It is the crunchiest. You can really break your teeth on that. Uh, but sometimes, as the diamonds are forming, other bits of rock or minerals get trapped inside of it as it forms. And then
impurities, if you will, yeah.
Impurities, yeah. So those impurities that you try to avoid when you're buying a diamond for your sweetheart are actually very scientifically interesting. And then diamonds may eventually reach the surface as part of a rock type called a kimberlite pipe. This is a crazy process. It's never actually been observed. There hasn't been a kimberlite pipe that has erupted in human history, I guess. But basically, if there's a very deep crack in the mantle, a column of magma will force its way up to the surface extremely quickly at up to 20 meters per second, which is 45 miles per hour. And it erupts at the surface. It erupts even faster, 200 meters per second, so 450 miles per hour.
Too fast.
Like a little diamond geyser.
Yeah.
It's fine.
Incredibly violent process, much faster than a normal volcanic eruption. You wouldn't want to be around when that happened. But what's left behind in the Earth is this deep narrow cone-shaped structure of kimberlite rock, which may contain diamonds and other rocks from the deep mantle, like garnets and things. So as the rock comes to the surface, those special high-pressure minerals that were down in the lower mantle change form, but any inclusion that's within a diamond is preserved because it's protected by the diamond.
Sure.
Right.
So they found this diamond in Botswana, and it came from about 660 kilometers down, which is about the boundary between the upper and lower mantle. And they were able to observe the inclusion with different like X-ray and spectrometry techniques that they give information about what elements are there, the composition of the mineral, its structure, and so forth. And they discovered this new mineral, which they called...
There's a new mineral?
Yeah, a new mineral. It had been theorized before, but this was the first time it had actually been observed. And they called it Dave Mowite. When I first saw this written down, I was like, how do you pronounce Davama? No, but it's there's this apparently well-known geophysicist named Dave Mao. So they called it Dave Mowite.
Dave Mowite.
Yeah.
Love it.
Amazing. I love science.
So this is not just a super cool discovery, but also by analyzing the structure of Dave Mowite, they found this potpourri selection of radioactive elements kind of worked into the crystal structure of this mineral, including uranium, potassium, radioactive potassium, and thorium. And this is important because geologists have long thought that radioactive decay in the mantle is responsible for a lot of the heat in the Earth, but they had no direct proof of it before. But now they have observed these radioactive elements. Crazily enough, it is so cool. Crazily enough, the same diamond also contained a type of ice that only forms at high pressures.
Hold on.
I heard about this. Yeah.
Yeah. I think they published on the ice a few years ago, and then just recently
Real hot
published.
Ice.
Yes. It's hard to imagine ice forming at such high temperatures, but under enough pressure it can, and it has an unusual structure. And they found this. So they found this high pressure ice, and they found this other high pressure mineral also within the same diamond, and all of this kind of helped pinpoint the depth that the diamond must have formed at. So they're able to really figure out what's going on 660 kilometers down. This is really amazing. And you know what it reminds me of the most is the way that insects and other things are preserved in amber. Completely different process, of course.
I was like, I'm like, where is she going with this? Like insects? I got you though. Amber, yeah. Absolutely.
Just bringing it forward into time in its little diamond shroud.
The amount of things that we've been able to gain from like things trapped in amber, or I guess in this case, things trapped in a diamond.
Yeah, that's what I have.
Amazing.
Love it.
All right, we're going to have a break. And when we come back, it'll be Kirk with our final segment.
Yay! I'm so excited. Welcome back, everybody. You know, right at the end of your segment there, Victoria, you mentioned Amber,
Mm-hmm.
right?
Where
And
are you going with
so,
this?
of course, you know what like immediately sprung to my mind. I think about Amber and things being preserved in Amber.
Jurassic
The
Park.
mosquito in Jurassic Park.
That's right, the movie Jurassic Park. All right, so obviously, y'all are fans. It's a really fun movie, and I think actually it pretty much still holds up pretty well after all these
Yeah.
years.
They used a lot of practical effects, not just CGI.
Yeah, well, we could go into a deep dive on all that, but I think definitely we've had an evolution of our understanding of dinosaurs, and we've learned since then. But as a movie, I think it holds up pretty well.
Yeah.
And there's one aspect of the movie that to the average person perhaps seems kind of far-fetched, and that something is parthenogenesis.
Right.
Now,
Okay.
the two of you may be familiar with this, but
I know where you're going
in the
with
mo-
this.
yeah, in the movie, the characters express some concern as they're like on the tour of the lab because they're breeding dinosaurs, and
Life finds a
they're trying
way.
to keep, yeah, they're trying to keep track of them, you know, in the wild. And the scientists explain like all the dinosaurs in the park are females, so no breeding can take place. And the greatest character of the entire movie, Dr. Ian Malcolm, played by Jeff Goldblum, gives a little speech about nature not being something you can contain. And then the scientists smugly ask him if he thinks that, you know, what do you think female dinosaurs are going to breed together? And of course, he famously says the line, no, I'm simply saying that life finds a way. Right? So it does indeed. Now, what happens in the movie is parthenogenesis, and that isn't something that was made up for the film. It's a real and very common thing, at least in some animals. It's an example of asexual reproduction. You basically have an unfertilized egg that begins to divide, and without being fertilized, it grows into an adult of the species, which is
Right.
pretty amazing. This happens in bees all the time. It's where all the
Oh, yeah.
drones
Mm-hmm.
come from. It also happens in certain species of frogs, and that's why in the movie they casually explain that they repaired missing bits of DNA using frog DNA. And I'm really not sure why, why you'd want to use DNA from a frog in a reptile when you have reptiles that you could use to get that DNA.
Or
But I
birds.
guess, you know,
Hollywood.
hand wavy plot reasons, right?
Science.
Yeah. So,
It's
well,
Hollywood.
not science. It's yeah, exactly.
Kurt.
So we discovered that the dinosaurs are indeed having young, right? And the frog DNA is to blame. Well, not so fast. You know, there's actually plenty of reptiles
Yeah.
that use parthenogenesis all on their own without having any frog DNA in them.
pretty
And
sure there's
dinosaurs are reptiles, so it's
Yeah.
like, you know, that this something that could happen even without the frog DNA, right?
Yeah.
Komodo dragons have been observed reproducing in this way.
Isn't
So
there?
have
I was just gonna say, I think there's a whole species of lizards that are just female. Aren't
yeah,
there?
probably the whiptails,
Yeah.
and then geckos. There's a bunch of snakes, including rattlesnakes and garter snakes that can do parthenogenesis. It's also been seen in sharks, which I think is pretty amazing. So yeah, life finds a way, right?
So cool.
Now, there was a story in the news this last month, though, that really blew my mind, and it involved the California condor. Did either of you
Yes.
see this?
Yes, I saw this
I
story.
think I did. Yeah.
Amazing.
So this is a species that became almost extinct, almost you could say functionally extinct. You know, back in at least extinct in the wild, back in 1987. And so all known birds in the wild were captured and taken into a breeding program in California. And this program started with just 27 birds. That's all that was left. I think at one point the number actually, before they kind of got it all figured out, the number dipped down to maybe 22 or something like that. Like
Yeah.
this was very close to being an animal that was extinct.
Yeah.
And there was an intensive captive breeding program, and they began re-releasing them into the wild in 1991, which is pretty cool. It was a really big deal when it happened at the time, I remember. Most current numbers I could find were for 2019 that said there was 518 condors, both that's including in captivity and in the wild, which doesn't mean they're in the clear yet, but
No.
It's a lot better than 27.
Yeah,
Yeah.
or 22. Now, with any captive breeding program, right, scientists keep very careful notes on which birds are producing which offspring.
Right.
You want to create the most genetically diverse pool moving forward, since you've had a bottleneck and there's not a lot of genetic variation to start with, so you want to maximize it and kind of figure out who's going to pair with who.
Yeah.
So, back when this started, they were keeping track of that, but they didn't have any like full DNA profiles for each bird. They just kept track of parentage simply by noting which male and female bird they had housed together, and then when young were born, it was pretty clear who the parents were, right? So scientists working for the San Diego Zoo Wildlife Alliance, much more recently, were looking at these more recent genetic profiles for the birds, and they noticed something strange. I think they were working with like old samples that had been preserved from some of these birds. There was two chicks with these really memorable names, SB260 and SB517.
So memorable.
Not only didn't seem to have genetic information from any known male, they didn't have genetic information from any male, period.
Whoa.
These two birds had hatched from unfertilized eggs.
That's crazy.
Which is so cool and amazing. Now, this, I would say that unfertilized eggs that start to develop has been seen in like captive bred animals before. It probably happens in the wild as well, but it's just, we don't document it. So captive bred pigeons, turkeys, and chickens have all had examples in the literature where you have an unfertilized egg that starts to develop an embryo, but usually the eggs don't hatch. Or if they maybe do, like the young are really malformed and they're not going to survive.
Yeah, something's wrong, yeah.
But both of these young condors did hatch out and survive. And in fact, there was no like sort of like, oh, this must be something strange with these birds. They were maybe a little different, but they were, for all intents and purpose, just condors. Sadly,
That's
though,
amazing.
yeah, they didn't live as long as we would have hoped. The lifespan of a California condor is up to 60 years.
Wow.
So they can live a long time. SB260 was released to the wild short time after being born, but sadly didn't do well and died of malnutrition just 2 years later. So did not survive very long.
Okay.
SB517 lived a little bit longer. It was kind of a runt though, and they ended up keeping it in captivity, and then it died of foot problems, which, as someone who works with raptors, I can tell you, foot problems can absolutely be an issue for captive birds. You have to be really careful with that. And so that bird, SB517, died at around 8 years of age, I believe. So better than the other one, but certainly not 60 years old. And here's the thing, birds do die of malnutrition in the wild, right? Yeah. And birds can die from foot problems in captivity. So this wasn't particularly surprising to the people it was a bummer, but it wasn't like cause for like, oh, something mysterious is going on here. These things happen with birds. And so we actually can't say for certain that these birds died because of their genetic anomaly, but I think it's probably considered to be the most likely reason that there was, you had sort of almost like an inbreeding situation. You just didn't have enough diversity within those genes to make up for any problems that had cropped up.
Yeah, maybe you had more of a chance to have foot problems or
absolutely
things like that. Yeah.
Or inability to digest food properly, things like that. Yeah. Or as we know, even things like eyesight and sense of smell and things like that can also affect your ability to find food. So there could have been any number of things wrong with that bird. Now, unfortunately, at the time, because their strange parentage had not been figured out when they were born, there were not a lot of like studies on them. Interestingly, part of the reason they didn't know that there was anything up with these birds is that the mothers were actually at the time housed with potential fathers. And they actually were breeding with those fathers and producing fertilized eggs. So these were just like anomalous eggs that happened to not be fertilized. So it wasn't like, oh, this bird that doesn't have a mate just had an egg. It's like, well, no, there was a father figure, if you will, housed with them. So they had no reason to assume anything was up. So the bummer of that is that absolutely no studies were done on them because they seem just like maybe not the best. Maybe not the best examples of condors because they were kind of runty and stuff like that. But there wasn't any reason to think that they were particularly special. So if scientists had known, you can bet they would have been studied extensively to learn more about this. So now then, birds are directly descended from dinosaurs. So you really can even properly say that birds are dinosaurs. So we finally have an example in real life, in the real world, where that we can see with our eyes when it comes to breeding dinosaurs, that nature or life finds a way.
Oh man, somebody should tell Jeff Goldblum.
Life does find a way.
I'm sure people have forwarded this on to him.
No doubt.
Oh yeah.
Twitter.
Well, that's what I have. I mean, I gotta go watch some Jurassic Park or hunt down one of the Jurassic Park pinball machines and go play that to get my Jurassic Park fix now.
That was one of the few movies that I actually saw in the theater on opening night. It was a trip.
Nice.
Very nice. Well, thanks for coming by, and thanks to everybody, and we'll see you again next week.
Yeah. Thanks, everyone.
See you next week.
Bye-bye.
Bye.
Thanks everyone for listening to today's show. Be sure to subscribe. New episodes drop every Wednesday, and we love sharing this strange world with all of our listeners. If you would be so kind as to leave us a 5-star review, that would be great. It lets other lovers of the strange discover the show. You can reach out to us on social media by searching for Strange by Nature Podcast on Twitter, Facebook, and Instagram. You can send us an email as well. Our address is contact@strangebynaturepodcast.com. If you want more information about the show, you can also check out our website, which is strangebynaturepodcast.com. Until next week, get outside, stay curious, and embrace the strange.